All right, grade 12s. We are preparing for paper one. So today I wanted us to look at some few questions on paper one, on functions. These are grade 11 functions. You just need to be well prepared. And I think I'll also send a follow-up video on calculus as well as financial maths. All right, so let's look at this question here. It comes from June 2017 question paper. The sketch below shows the graph of g of x, which is given with this equation here. So sorry, g of x is given as a into x minus p all squared plus q, and h of x is given as mx plus t. Let's remember that the second equation, this one is linear equation. It's a straight line, the equation of a straight line, and the g of x is the equation of your height of your parabola. So that's what those two equations are for. But before we attempt these questions, you need a background knowledge. Remember, when you are given an equation in this form, in a complete square form, you must always look if you are given the p-value is your x-coordinate of a turning point and your q-value is the y-coordinate of a turning point. And in order for you to find an equation, you always need to see if you are given any additional point on your graph. So if you notice there, we are given a point of 3 and 25, which will help us or assist us in finding the equation. All right, for 2 marks, which is the first question there, write down the values of P and Q. The values of P, according to what you see here, is 3, or I'll write this as 36.1. The value of P is -3, and the value of Q is the Y value there equals to 1. Okay, easy 2 marks. 36.2, determine the equation of G. Um, our g of x is this equation, the equation of parabola. So by luck, we already know what the p-value is and what the q-value is. It's only a matter of substitution and use the second point to determine the value of a. So what you will write, substitute the value of p and q in the equation. We get a into x because p is -3 here. When we substitute it there, the equation changes and become +3. That's because you are substituting a negative p and it's subtracted there. And then we have the value of q. The value of q is 1. Now we have additional points that we can use to determine the value of a. So we are going to subs the second equation of 3 and 25. So our x value is 3, our y value is 25. That would help us to find the value of a. So 25 would then equal to a into 3 minus 3 plus 3 all squared plus 1. Right, algebra is key here. Remember, you would have to, because we are adding 1 to whatever answer we're going to get when we multiply a with the answer, with an answer here, we transpose the 1 to the other side. So we get 25 minus 1 equals to a times 3 plus 3 is 6 squared. We get 36. Right, 25 minus 1 is 24, which equals to 36a. We then divide both sides by 36, and we get our answer of a being that the number that divides into there, it's going to be 4 into 24. It goes 6 times. Let's use 8, no, 6. 6 into 6 into 24 goes 4 times, and 6 into 36 goes 9 times. 6 into 36 goes 6 times. My apologies, it goes 6 times. And if we simplify this further, we're going to get 2 out of 3. Okay. Oh yeah, we should have used 12 in this context. All right, so that's the value of A. Now we can write the equation. We are not, well, if you rewrite the equation, you can write it the way it looks like. So we just write g of x equals to, the A value is 2 over 3 into x plus 3 all squared plus 1. So that's going to be the equation of our g of x. Write down the values of t and m. First and first, we need to understand what is the value of t. The t that we have here in our linear, that's the y-intercept, and the value of m is the gradient. The beautiful thing about this graph is that we must remember that at t, g of x and t of x, or g of x and h of x, share the same y-intercept. What you would then be expected to know is to simplify this equation and get y-intercept from here, or you can just determine y-intercept by by substituting 0 in g of x. That will be the coordinate at t. So we're going to look at the x value there, or the x value is going to be 0. So we're going to look for the y value at t. Once we have the y value at t, we are going to use dual intercept methods. Yeah, dual intercept method, because we do have two intercepts on a straight line, and we are going to use the dual intercept methods to determine the equation, which is the simpler way to find an equation of a straight line. But these are the processes and the steps that you need to take. What you are then going to do first is to determine the y-intercept at t. So you can write at t, right now I'm answering 36.3, at t, um, x equals to 0. So we are going to say g of 0 equals to 2 over 3 into 0 plus 3 plus 1. If you multiply 3 with this, I end up with 2 plus 1, and your answer is going to be 3. So the coordinates here are 0 and 3. Now, I haven't answered the question of of determining the equation of h of x. Now, to find the equation of h of x using the intercept method, this is already that y value of our y-intercept is already the value of t. We just need to find the gradient. So h of x will then equal to mx plus 3. Then we follow that with substitution of point S. So if you look at substitution of point X, Y is 0, X is 7. So we will then substitute here. Maybe let me write that for you to remember. We are then going to subs the coordinates of S, subs point 7 and 0. And then we get 0 equals to m into 7 plus 3. We then transpose 3 to the other side. We get negative 3 equals to 7m. Divide by 7. We get m equals to negative 7 over 3. Now, we have found the coordinates of m and t, and we are sorted. Here we know that t is going to be the value of 3, and m is the value of 7 over 3. You don't necessarily have to write the equation. All right, next question. Calculate the length of QR. So let's look at how does QR look like. If you look at QR, it is a vertical length. So since it's a vertical length, it has the vertical length has the equation. It has the equation, I'll write it as length, or if you want, you can call it distance. It has the equation of y2 minus y1. That's basically what we need. Once we know what is y2 and once we know what is y1, we just subtract the two, we will be able to find the length. Now, the beautiful thing is that we already know our y2, it's 25 because that y2 is on the quadratic equation. We just need to know what is y1 down here. So it's the y value on a straight line with the same x of 3. So we will then take this 3 here and substitute it in this equation, in the straight line or linear equation. So we are going to substitute this 3 in this equation so that we can find the y value at r. And once we know the y value at r, we just subtract those two. We will get the equation of, or we will get the magnitude of QR. Right. I would say, what is the y at r? So y at r will then be, we have to rewrite the equation of our straight line. But the beautiful thing about the equation of a straight line is that we already have determined t and m, so we are not going to worry that much. We have 7 over 3x plus 3. All we do is to subs the x coordinate from the from q down to r. So we are going to subs x equals to 3. From here, we are then going to get h of 3 equals to negative 7 over 3 into 3 plus 3. 3 times that, or 3 times negative 7 over 3, we get negative 7 plus 3, which then gives us negative 4. I will have to confirm something is off here. Oh, yeah. Oh, my apologies. I made a mistake somewhere. I made a mistake. Let me just quickly correct that. Um, so we divided by 7, not by 3. I was very worried about that. Apologies. So here is a 7. The answer should be negative 3 over 7, not the other way around. All right. Yeah. So that was the mistake that I made, and I was worried about that answer there. So this becomes, the equation is going to be negative 3 over 7. Again, we get, that's fine. We get negative 3 over 7 times 3. What I get here is going to be a fraction. We just need to know how to work out the fractions. So the answer here is negative 9 over 7. Please excuse my mistake there. All right. So going forward, we then get 7 times 3, we are going to get 21 minus 9 plus 21. It's going to be 12 over 7. Yes, we are going to get 12 over 7. Now, that's the coordinates of the y coordinate at r. Now, to find our length of QR, we are going to say it's y2 minus y1, which equals to 25, subtract 12 over 7. Right. And then the answer, I'm just checking with my calculator here, 25 minus uh, 12 over 7. We get something like 163 over 7 or units. Well, you can write it as a decimal number, and we round it off to two decimal places. Um, so I will write it, it's going to be 23.29 units. All right. That's going to be the distance um, between Q and R. Going forward, um, we will then look into 3.5. So 3.5 says write down the turning point of P if P of X is negative G of X plus 5. This is a transformation question. So because this is a transformation question, you need to know, you need to understand what transformation took place from G to get G. All right. So the question is what transformation took place? So I'm going to try and maybe cut this piece out. I'm unable to. All right. So my key part is this question 35.6. So we have two parts here. Negative G of X means it has been transformed by reflection on the x-axis, and then plus 5, it was then translated or it was shifted up by 5 units. So there was a reflection on the x-axis, meaning that the y coordinate of our turning point was then reflected to be negative, or the whole function was then reflected to be negative, and then to face down, and then it was shifted by 5 units up. This is a two marks question. Um, so if you are given f of x, for example, equals to x, when we say negative f of x, we are then we are then reflecting the whole function of f along the x-axis line. So your equation becomes negative x. Let's say you have f of x plus 1. So the negative f of x becomes negative of the whole function of f, which then becomes a reflection on the x plus 1, which we end up with negative x minus 1. So you guys, you need to remember this laws of transformation. So what will happen here is that the function of G is going to be transformed. So the Q value would change in sign. So the Q is going to be reflected on the X itself. So it's going to now become a negative Q. If it was negative, if it was positive, like in this context, we have positive 1, it becomes negative 1. And then our A value is also reflected, which now becomes a negative. But the key part here is we need to know what are the coordinates of a turning point. So the coordinates of our turning point, this is the part that is affected. So the +1 is going to be affected. And it's going to be affected by reflection and also by translation. So it's reflected, meaning that it becomes negative. The x coordinate of the function is not affected because we are not reflecting it on the x line or on the y. We're reflecting it on the x. So the x parts are not affected. Now, from here, we then transform or translate or shift the graph up by 5 units. All right, so how does it look like? We know that g of x is, I'll just go back a little bit, 2 over 3. That's 2 over 3 x plus 3. Yeah, x plus 2 plus 1. So x plus 3 all squared plus 1. But the moment we do another function, which is now called p of x. So p of x is the reflection of g of x on the x-axis line and the translation by 5 units up. The equation of p of x would then be, if you want to, because this is a 2-mark question, if you want to, you can write the p of x and substitute g of x in the equation. If you don't understand the transformation that has happened, you say negative, then we substitute our g of x and we add 5 because we are also translating it upwards. So this is going to be substitution method. I'm using a substitution method for your own understanding and clarity. So here we're going to multiply everything by -1. We get negative 2 over 3 into x plus 3. I did mention that the x plus 3 is not going to be affected. -1 plus 5. And we end up with negative 2 over 3 of x plus 3 plus 4. So technically what we need to write as our coordinates of a turning point at P, our coordinates of a turning point will then be x is -3 and y is 4. So these are the coordinates of our turning point. Is it necessary for you to have substituted for your own benefit? Yes, I would advise you to have substituted there. Last question. For which values of k will g of x equals to k have two unequal roots? All right, we need unequal roots. What we are then going to do here is we substitute k in g of x, and we have to determine unequal roots. For unequal roots, they are not specific. Are they unequal and rational, or are they unequal and irrational? So there is no specifics here, irrational. So we can get any unequal roots. It doesn't matter if we get rational or irrational. So in this case, we are then going to take the statement as any real roots. So they must be unequal and they must be real roots. All right. We are not going to choose rational, and also we are not going to choose irrational. So this, we need to remember the conditions of our nature of roots. We have to write our g of x equals to k What we are then going to do here, we substitute our equation of g of x and also work with k there. We have 2 over 3 bracket x plus 3 squared minus plus 1 equals to k. Let's be careful here. We then have to work out the roots, the nature of roots. So here we are going to move this to the other side or transpose 1 to the other side so that we can solve the values of x. And then we also have to multiply further. So we are going to get 2 over 3 into x plus 3. Then we say this is k minus 1. That's a square there. We then multiply everything by 3 over 2 to get rid of 2 over 3, 3 over 2 here, and then this must be multiplied by 3 over 2. What then happens after this? We are going to square root. So we have x plus 3 equals to 3 over 2 into k minus 1. So this is a square. And then to get rid of a square, we are going to square root, and that's what we are looking for. X plus 3 will then equal to the square root of 3 over 2 into k minus 1. Then whatever is going to happen here, it's plus or minus, whatever we are going to get on this side is going to be x equals to plus or minus the square root of 3 over 2 into k minus 1, and then minus 3. But the question wants us for which values or value of k will make the solutions to be unequal. K can never be less than -1, because when k equals to 1, we are going to get 0 and in here, which is one of the solutions. So when we get 0, we only get one solution of x. And actually, yeah, we get one solution of x, which is -3. But any value after that, if we get k being greater than 1, we will get unequal roots. So in this case, we are going to say when k is greater than 1, we are going to get unequal roots. All right. That's basically it. For all values of k that are greater than 1, we will get unequal roots. I explained algebraically so that you guys can see how we got the values, but you could also just substitute there and remember that k will affect what 1 looks like. And then because we are adding some or we are subtracting something from 1, and to make roots to be unequal, we just need to make sure that we do not get 0 or a negative answer in this bracket here. All right. I hope this will help you guys in preparation. I will send another video today on functions or on calculus, and then after that it will be followed up by financial maths video. Thank you.